If you're watching this before you've been in class on Thursday and Friday this week, then you haven't done the Mr. Stretchy activity, and we're going to be doing that to help you to clarify about similar figures. It's an introduction and how to do dilations. So this video is all about similar figures. You can see to help you with your notebook, I have put that it has been assigned on 9-8. So similar figures, in most cases, what you think of when you think of similar figures is that they are the same shape but different size. And that is the basic definition of two figures being similar. All right, so we need to talk about the exact definition of similar. How do we know that two figures are similar? So at the bottom, you can see that figures are similar if corresponding angles are congruent and if the lengths of corresponding sides are proportional. So let's start with corresponding angles being congruent. Look at the figures above. You can see that we have angles that are congruent. Angle B is congruent to its corresponding angle, which is angle H. Okay? Angle A is congruent to angle G. Angle C is congruent to angle I. And angle J is congruent to angle D. All of the angles have to be congruent if they're corresponding. All corresponding angles have to be congruent. I cannot say that enough. If the angles are not corresponding congruent, the two figures are not similar. They cannot be. All right, so let's talk about the second half of this definition where it says, the lengths of corresponding sides are proportional. Okay, so think about proportions. Okay, so that means that if you were to take one side and divide it by the corresponding side, you would get the same number. I'm going to give you a number example in a minute. But look at side AB and look at its corresponding side, which is HG. If I were to take AB and divide it by HG, I should get the same thing if I were to take two other corresponding sides and divide them by each other. If I were to take CB and divide it by HI. And that should be the same as if I took the length of CD and divided it by IJ. And if I took AD and divided it by GJ. Okay, we'll talk about that on the next slide. Okay, a similarity statement is the same as a congruent statement, except we're using a different sign. So here we have our first polygon, okay? So we're going to say polygon, I'm even going to draw it. A, B, C, D is similar. The similar sign is just the squiggle sign, okay? We don't put the equals underneath it. So now we have to match it up. Polygon ABCD is similar to, got to make sure everything's in the same order, so I know that A is corresponding to G, so it's G, H, I, J. Okay, so that's your similarity statement. So let's look at the next page where I have an example with two triangles. All right, so you can look at the triangles and you can see that all three angles are congruent. All right, let's give them some names. A, B, C, D, E, F. Angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. Now, next thing we got to do is see about the sides. All right, so let's see if AB divided by DE, that's the ratio, the proportion, is the same as BC divided by EF, and if that's the same as AC is divided by DF. All right, so I get 15 over 6. So what's that? I'm going to actually do the division. 15 divided by 6 gives me 2.5. Okay, for BC, that's 20 over 8. 20 divided by 8, guess what? 2.5. and AC, which is 25 over 10, again, 2.5. That means that all of the sides are proportional as well. So your similarity statement is A, B, C is similar to D, E, F. You might remember this as well. This proportion is called the scale factor. This is how much a figure is dilated. Is it grown, or does it grow, or does it shrink? In this case, the figure has grown from this one to this one by a scale of 2.5. So that's the end of this video. As we do the dilation activity and move on, we will get deeper into it. Make sure you answer the questions. They're right underneath this on the daily lesson plans.